Alright, so I'm going to review with you different ways to factor. So I'm going to start with if there is a greatest common factor. So the first thing we're going to do is we're going to try to find, I'm going to start with number 3. We're going to try to start by finding what goes into both 48w squared and 36w. So the first thing I think of is the number 4, I believe, goes into both of these. And so I'm looking for the greatest common factor. Is there another number greater than 4? So not that I can think of, so I'm going to try 4. And then there's w squared and w, so I'm going to take out a w. So if I do that, I divide and I get 12w minus 36 divided by 4 is 9, and the w's will reduce. And so if I look at this, 12 and 9, a 3 can come out of that. So I should have done, instead of taking out just a 4, I should have taken out a 12. So I can then take the 3 out here and get 4 times 3 is 12. And if I divide by 3, I would get 4w minus 3. So if I had noticed right off the bat that it was 12w was the greatest common factor, then I would have divided this by 12 and I would have got 4w. I would have divided this by 12 and I would have got 3. So same answer either way I did this. I just thought that right off the bat I saw a 4 and I didn't quite think of the 12. So once you factor something out, if you see that there's something still in common, you want to then take that out as well, because you want to find the greatest common factor, not just a common factor, but the greatest. So if I did question number 6 now, I would be looking for what goes into both of those. So, or all 3 of them, sorry. So 30, 12, and 6. I know the number 6 goes into all of those. And there's 4 m's, 3 m's, and 2 m's. So I know I can take out 2 m's from each of them. N cubed, n squared, and n. So all of them have at least one n. So 30 divided by 6 is 5. If I take 2 m's away from m to the 4th, I get m squared. And if I take 1 n away from n cubed, I get n squared. So now I'm going to take out 6m squared n here, and I get negative 2 m n. So I took out 2 m's, I took out 1 n, and this is what I got. And then last but not least, if I divide 6 by 6, I get 1. M squared and m squared will reduce, n and n will reduce, and I will get just 1. So I factored out the greatest common factor, which was 6m squared n, and this is what I got. So the next thing we're going to do is difference of squares. And the first thing you always want to do is take out a greatest common factor if you can. So I'm going to start with question number 10. And I know that 2 goes into both of these, and an x goes into this. So I'm going to take out a 2x. So 98 divided by 2 is 49, and 8 divided by 2 is 4, and this is what I get. So I took out a 2x, and now I need to do difference of squares here, where the perfect square of 49 was 7 and 7. And the perfect square of 4x squared is 2x and 2x. And 1 needs to be positive, 1 needs to be negative. So this is what I get. So first start with taking out your common factor, then split up your perfect squares. Alright, for this next set we're going to do basic trinomials. And again, you always start by looking for the greatest common factor. So like question 14, I see that they all have an x. If I take out an x, I get x squared plus 16x plus 64. And then I bring down the x and I try to split this trinomial. What multiplies to x squared is x and x. What multiplies to 64 is 8 and 8. And since I need these middle terms, that would be 8x and 8x. I need these to add to 16, so they'll add to 16 if I add them both. So I can either leave my answer like this, or see how this and this are the exact same thing? I could say x plus 8 squared. either way is correct. So the next set we have is factoring trinomials that have a number in front. So again, the first thing we always do is look for that common factor. So I'm going to do number 19, where my common factor is, let's see, 2, I believe. So if I take out a 2, I'm going to get 3w squared minus 14w plus 16. And I need to split this. Don't forget to bring down the 2, that's part of your answer. What multiplies to 3w squared is 3w and w. What multiplies to 16, we can try 4 and 4. I could also try 2 and 8. I could also try 1 and 16. I'm just going to start with 4 and 4 and see where that gets me. So 4w and 12w. Will 4 and 12 give me 14? No. So I need to try something else. So I'm going to erase that. I could switch the 4 and the 4, but that's not going to do me any good. So instead of switching, I'm going to switch numbers and try 2 and 8. So if I put 8 here, I'd get 24. So I'm going to put 8 here and 2 here and see if that gives me anything. So that would be 8w and 6w. So that would be negative and negative. So if both of those are negative, I get negative 14, and negative 8 times negative 2 give me positive 16. So this is my factored trinomial. So notice that first step in everything is always to take out the greatest common factor. Like number 17, there is no greatest common factor, so I would just go straight to this, break down what multiplies to 2x squared. For 28, break down what multiplies to 28. You could try, 14 and 2. You could try 7 and 4. You could try 28 and 1. So how do you choose which numbers to try? I always start by trying the 2 that are closest together, like I did down here with 16. So I tried 4 and 4. Those are closer together than 8 and 2 are. For this, I might try 4 and 7. But remember, if I could put a 2 with a 4, that means there was a common factor of 2 up here, and there was not. So I can't try 4 there. Instead, I'll try 7 here and 4 here and see if that works. So I'm going to let you finish off these questions. Good luck.